We are here to discuss the constructions of triangles, especially related with the similar triangles. But before to start the construction of similar triangles, let's discuss how to divide a given line segment in a given ratio. Suppose we have been given a line segment of certain length and it has to be divided in ratio 2 is to 3. Since ratio is 2 is to 3, so 2 plus 3 comes 5. So what we will do here, suppose this is the line segment which needs to be divided in ratio 2 is to 3. We will draw another line segment inclined with an acute angle with the given line segment, and since ratio is 2 is to 3, then what we will do, 2 plus 3 comes 5. So we will take here 5 points at equal distances, something like this. You can use your scale also for doing this, and 1, 2, 3, 4 and 5. From the fifth point, just join the end point of the line given line segment, and from the second point go on drawing a line which is parallel to this one, that comes like this, and for that purpose you can draw the corresponding angle which makes to be equal here. So something like this, a line will come which will be parallel to this, and now it is this one is the exact point which divides this given line segment in ratio 2 is to 3. But how can we be as certain about this point? Actually, we know that if a line is drawn parallel to a given line, given side of a triangle, the rest two sides are divided proportionally. Since we have drawn this line parallel to this, so the ratio 2 and 3 will become the ratio of these sections. So that is why we get here 2 and 3. So this point divides this line segment in ratio 2 and 3. So students are required to use compass and pencil to draw this very important construction. So let's come to the triangles. Suppose we are given a triangle and we have to construct another triangle, another similar triangle, which each side is 2 by 3 of the sides of the given triangle. Then how it can be drawn, how it can be constructed? Let's see here. What we will do, suppose this is the triangle, and we have to make another triangle similar to this, and in that similar triangle each of the new triangle should be 2/3 of each side of this given triangle. So 2/3, 2 by 3. So what we will do here, we will take 3 points at equal distances, and the last one will be joined with this endpoint, and 1, 2, this is the second one now. So from here just draw a line parallel to this using corresponding angle, and that line goes like this. So this point we have got here, this is 2 of the whole, 2/3, this line segment of this length is 2/3 of the whole, and from this point now go on constructing a line segment parallel to this one, and that goes like this. And now suppose this is A, B, C, so it will be C dot, it will be B dot. So our required triangle is here, A dot, not B dot, A dot, B and C dot. Here A dot, B, C dot is similar to triangle ABC. and each of this side is 2 by 3 of the each of the side of the bigger triangle ABC. Last one. This is the second construction, and last construction related with the triangles is to draw a similar triangle, each of whose side is 4 by 3. 4 by 3 means what? Numerator is more, denominator is less. Here numerator was less, 2 by 3, and denominator was more. But in a new construction, we are going to learn how to draw a similar triangle, each of whose side is 4 by 3 of the each side of the given triangle ABC. So only a little difference is here, and both these constructions are very important from examination point of view. So what we'll do here, see, just imagine we have got a triangle here ABC. Same thing will be repeated. We will draw a line like this. Suppose our ratio is 4:3. So we will take 4 points at equal distances like this, 1, 2, 3 and 4. And 4 by 3 we have to draw now. So from the third one, the last point C will be joined. And when we draw a line parallel to this one, it will go outside of this triangle. And naturally, BC will be required to be extended up to C dot. We have got C dot here, and from C dot, taking this angle equal to this angle, corresponding angle, we will draw another line parallel to this, and that comes like this. So now extend BA to A dot, and now it is the final construction, A dot BC dot. A dot BC dot is similar to triangle ABC. Triangle A dot BC dot is similar to triangle ABC. So this is the process, and this also needs a regular practice to be made by the students. You just use your compass, scale, etc. to draw this and have a good practice of it. I'm sure that you will be in habit of drawing this type of constructions very soon. The next one is related with the circle chapter, and there you have to draw tangents from a point outside the circle. So let's see how that can be drawn. Suppose we are having a circle. Suppose we are having a circle like this. Here we got a circle like this. Here is the center. So you just produce this like this. Suppose from here we have to draw a tangent. Then draw a perpendicular bisector of O and A. Perpendicular bisector, that comes like this. This point is very important because we have to make it center, taking this one. Suppose this is M. So taking AM as radius, and we will move our compass like this to take 2 marks, one at the top, another at the bottom, and just draw like this. It will give 2 tangents. So this is very easy construction related with the circle. But students, one thing please note down here that here we have used the center of the circle. Another question comes to draw 2 tangents without using the center of the circle. How can it be done? Let's see. And this is the last construction suitable for class 10th CBSE board. So without using the center, how can we draw the tangents? Suppose center is here, but you are not permitted to use this center. So just draw a line like this. This we call secant. So from here to here, you just draw perpendicular bisector to get its midpoint like this, and from taking this midpoint as center and this AM as radius, go on constructing a semicircle which comes like this. And now this distance, you just note this distance, this is also equally important. Suppose this is B. So now we will draw perpendicular bisector of AB, and suppose that comes like this. So this point is very important. Taking this point as center, once again you just notice that this point is the midpoint of AB. So taking this center and taking this as radius, cut two marks here. In this way it comes, and this is the required tangent. Means required tangent is dP or dt t dot. dt equal to dt dot are the required, dt and dt dot are the required tangents, and both are equal, because we know from geometry that tangents drawn at the circle from a point outside the circle are equal together. So here dt and dt dot are both are equal. So for this video, let's tell me goodbye to all of you, and I will be back very shortly with some new portions of your mathematics. Till then, namaste.